as a product. So for you to find momentum, the symbol for momentum is P. Now P is for linear momentum. Because we're also going to have angular, we use L, but we'll discuss that when we talk about angular motion. So momentum is given as a product of mass and velocity. You know mass is in kg, that's SI unit. SI unit for kg for velocity is meter per second. So this is the SI unit for momentum. Kg meter per second. But I want you to realize one thing here. When you are talking about velocity, how do you find velocity? Remember, velocity is okay. Let me use something else first. Remember the second law of motion. Force is mass times acceleration. And now we know that mass times acceleration. The acceleration is given by the change in velocity over the change in time. If you get the change in time down, you multiply with the f. That will give you f. Change in time is equal to m change in v. So if you get this velocity, you say it's change. It means that even the momentum is going to be change. So change in momentum is given by mass times change in velocity. Now force multiplied by the change in time or the impact time, it gives what we call impulse. So impulse is equal to change in momentum. We call this equation as the impulse momentum theory. Very simple, isn't it? It's something that you should not forget. When we talk about momentum, we have got two types. We have what we call elastic and inelastic. Because what happens is that in momentum, as two objects are moving, let's say this object is moving, it is going forward. And then there's another object that is coming from this direction. These objects can hit each other. So there is collision. So one of the important things that we're interested in finding in momentum or dealing with in momentum is collision. So collision can be elastic or inelastic. If the collision is elastic, it means that momentum is conserved, kinetic energy is also conserved. Please take note of that. Now, in inelastic collision, momentum is conserved, but kinetic energy is not conserved. So, in other words, in any type of collision, momentum is always going to be conserved, but kinetic energy is not always conserved. Is this clear? Do we have people that have a question? Second one here. You know, physics always makes sense when you write at least a diagrammatic representation. So at this point, their combined mass is going to be 2m. And we've been told they skid together 6 meters in the original direction of motion. So the original direction is this same direction in which they are going. Okay. If the stopping force is 0.7 times 10 combined weight of the cars. So in other words, at the point when these two cars hit each other, they stuck. So at that point, the brakes are off or the brakes are locked, meaning that there is no forward force. Okay, but there is a force that is acting in the opposite direction, and we call that as the braking force. So we have got a force in the opposite direction. We can also call it a kinetic friction because it is stopping motion. So that is the force that we have acting in the opposite direction. And we've been told the coefficient of friction is 0.7. So the question is find the approximate speed of car 2 just before the collision. You know, the interesting thing about this question is first car 2 is moving at a certain velocity v, which we don't know. Car 1 is at rest, meaning it's not moving. So at the point that car 2 will be hitting car 1, it is moving with a certain velocity. Okay? And then when they stick, at that point when they stick, you are going to count that as the initial position that they will start moving together. So in other words, we know that these two cars are to skid for 6 meters. So meaning that the combined velocity at this point is going to be 0. But what will be the initial velocity of these two cars when they stick just at the beginning? You see? So for us to find that, we are going to say at the beginning when they've just stuck, what equation are we going to use? We use equations of motion because we have got distance, we have got final velocity, we have got initial. Okay, actually, we want to find the initial speed, but we also know if the stopping force, so we know the stopping force, okay, which is 0.7 times the combined weight. So which equation can we use? We can use actually laws of motion. We can say that the net force, so this one is a combination of laws of motion with momentum. So net force is equal to, what is the force that is going in the forward direction? Remember, both cars had their brakes on, so there is no forward force, it's 0. How about the force opposing motion? It is kinetic friction. And you know that net force, second law of motion, is given by mass times acceleration, and that will be equal to negative Fk. And you already know, they've even told you the stopping force is 0.7, but you already know that kinetic friction is given by coefficient of kinetic friction times normal force. So we are going to say Ma is equal to negative coefficient of friction times normal force. And normal force is given by mass times gravity. But remember, this is the total mass and then times gravity. Okay? And since I'm saying this is total mass, even this mass here is the total mass. So basically, those two guys will be able to cancel out. So this mass will cancel with this mass. The acceleration is going to be equal to negative mu g. So the coefficient of friction will be in total, that is 0.7. So the acceleration is going to be negative 0.7 multiplied by 9.8. So this car is actually going to be having a negative acceleration. The meaning is that it is actually decelerating because it is going to rest. So that will be negative 6.86 meters per second squared. But now let's determine what is the initial velocity at which the cars were moving just at the moment that they had to stick. So there we are going to say v squared is equal to u squared plus 2as. Remember the final velocity, we've just said that that's a 0 squared, and then the initial velocity of the cars just at the point that they stuck, we said that is v initial squared, and then plus 2, the acceleration, negative 6.86. The distance they covered before stopping is 6. So we'll take this times the other side, so we're going to have v initial squared being equal to 2 multiplied by 6.8 multiplied by 6. Remember, this is a negative value, but if it goes the other side of the equation, it becomes positive 82.32. And then square root both sides. So the initial velocity is going to be equal to 9.073 meters per second. Now, I want you to understand this. That velocity that we have found is when the cars have just hit each other. Now we can deal with momentum. Okay? There was nothing about momentum there. So how do we deal with momentum? So for momentum, the momentum before impact, remember we said that for any type of collision, momentum is always conserved. So we'll say that the initial momentum initial is equal to momentum final. But remember at the beginning, we had the momentum of the first car and the momentum of the second car. So we'll say the momentum of the first car, that is m1 v1, actually at the beginning we'll not say it is v. But what letter did I use initially? Okay, since initially I'd used a v, I can still, but let me remove a v, because at the beginning, the velocity for this first car, we are going to call it u, okay? So this is going to be u2. This one is going to have its velocity, we'll call it u1. That's the initial velocity. So we're going to say m1 u1 plus m2 u2. This is the initial momentum. So the way you find momentum at the beginning is you get the momentum of the first vehicle at the beginning plus the momentum of the second vehicle at the beginning. It should be equal to the final momentums. But because remember the two cars had to stick, so it means that they were moving together. They had the same mass and they had the same velocity. So we'll simply say combined mass. I've used the capital M, or I can say mass total, and then times the velocity, because I've used V here because they'll be now moving at the same velocity. Now this same V I'm putting here is that same V that we are from calculating in the previous uh, operation. Okay, the velocity is just at the point that they had to stick. So the first car, the mass we've been told is M, because they had the same mass. But we are told that the first car was at rest, so velocity is 0. The second car was moving, its mass is m, but its velocity we don't know, and that's the one that we are calling u2. And that should be equal to, remember the second car was actually moving, it's the one that had to hit the other one from the back. The combined mass is going to be 2m. And then the velocity, we have just from calculating that velocity at which they were having just at the point of impact, and we calculated 9.073. So this will give us m times 0 is m, so this will just be m u2 is equal to, so we'll multiply 2 times 9.07, so that is going to give us 18.14 m. So you see that this m will cancel with this m. So u2, the velocity at which the first car was moving for it to hit, sorry, the second car was moving for it to hit the first car from the back, is 18.14 meters per second. Okay, you can see that's the value there. Is there anyone that is lost at any given point? Anyone? If you are okay, just show some reactions with any emoji. Only two people have reacted. Okay, to help you, let's use another question. I'll still give you this tutorial sheet, the video also, right? So let's do this one also. Please follow it well. For momentum, you always have the initial point and the final point. This is very, very important. You always look at the initial momentum of each object and the final momentum for each object. So question 2 is saying a bullet of mass 10 grams and traveling at a speed of 500 meters per second strikes a block of mass 2 kg. So this guy is having 2 kg mass. The bullet is having 10 grams mass. Okay, the block is suspended by a string of length 5 meters. So from the very top there to the very bottom here, this is 5 meters. Okay, there. The bullet goes through the block in a very short time, and the center of gravity of the block is found to rise a vertical distance of 10 centimeters. So this is 10 centimeters, this vertical distance that it has risen. What is the speed of the bullet just after it emerges? So what is the velocity of this bullet when it emerges, okay, from the block? So again, we'll use conservation of momentum. Momentum initial must be equal to momentum final. This is what we have to know, very vital here. So final momentum is the same as initial momentum. But we have got two objects here. Let me call the bullet as the M1 and then the block as M2. So we'll say the momentum at the beginning M1, U1, that's momentum initial for the bullet. And then the momentum initial for the block is going to be M2, U2. Because the bullet didn't stick to the block, so we are going to calculate their individual momentums. So say now momentum M1, but now here we use the final velocity V1. This is for the bullet. And then plus M2 V2. This one is for the block. Remember, we've been told that the bullet was traveling at a speed of, it strikes a mass of 2 kg, which is suspended. Okay, there's a Juliet, your hand is up. There's a question. Okay, all right. So remember, the bullet was moving at 500 meters per second. So what is the mass? The mass is 10 grams. But guys, we don't work in grams in physics. You work in kgs. So divide 100, oh sorry, divide 10 by 1000 to convert it to kg. So that will be 0.01. The initial velocity at which it was moving was 500. And then plus the block had a mass of 2 kg, but it was initially only suspended. It wasn't moving, so its initial velocity was 0. And this is going to be equal to m1, the mass of the block, sorry, of the bullet is still 0.01, and then multiply by v1. We don't know, that is what we are trying to calculate, v1, the velocity at which it had to come out. And then plus m2, the mass is 2, but we don't know v2 also. Okay, so this is going to give us 0.01 times 500, that is going to be a 5, is equal to 0.01 v1 plus 2 v2. So v2 is the speed at which the block is going to be moving. There's a question, Messi? Mhm. Okay, so for the bullet, initially it was moving at a velocity of 500 from the question, but the block is just suspended on a spring, so it doesn't have any momentum, or it doesn't have any velocity. That's why I've put a 0 there. So 0.01 times 500 is a 5. and then plus 2 times 0, that is still a 5. Does that make sense? Thank you. Now I want you to look at this. When the Because we have got two unknowns, v1 and v2 are both unknown. We have got a suspension like this. We have got a mass here. And then after being hit, the mass had to rise. So at this point where we have reached, this is where we now combine topics. As you've seen, we are still going back to forces. Okay, so this object had to rise. So remember, at this point, at the moment that a bullet hits this mass is going to gain a velocity. Take note of that. It's going to gain velocity. So the mass is, remember, the mass is going to have a velocity v2. Just at the time or the moment that it is hit by the bullet. Because initially it is just suspended, it's not moving. But at the moment it is just hit by the bullet, it will start moving. That is why it ends up going on top. So what kind of energy does it have at this bottom? It has got kinetic energy. What energy is it going to have on top? Because it is being elevated. As long as something that is at a certain height, it has got potential energy. We are just from doing work, power, and energy. So I believe you understand this. So we are going to use the conservation of energy. Okay. Initial energy, energy initial is equal to energy final. This is for the block. The initial energy for the block at the bottom here is only kinetic energy. And all the kinetic energy will actually be converted to potential energy at the top. Okay. So kinetic energy at the bottom is equal to potential energy at the top. I meant to say kinetic energy, all the kinetic energy at the bottom will be converted to potential energy at the top. Kinetic energy is half mv squared. Potential energy is mgh. So the mass is going to cancel out. So this is going to give us V being equal to the square root of 2gh. I've just gotten these two and multiplied with the gh and then square rooted both sides. So this is the formula that will give us V2. So therefore V2 is going to be equal to 2 by 9.8, and then the height through which it had to rise has been given. That is a 10 centimeters. Now 10 centimeters converted to meters, that is a 0.1. And then we square root this guy. So that is going to give us square root of 2 times 9.8 and then times 0.1. That is going to give us a 14 meters per second. So this is V2. This is the velocity that the block is going to gain just after the bullet hits it. So we can now get the equation. Back to equation 1. 5 is equal to 0.01 V1. So 5 is equal to 0.01 V1 and then plus 2 V2. Where there is V2, put 14. And this is going to give us 0.01 V1 being equal to 5. I'm going to take this number to the other side and it's going to become a negative value, isn't it? So 2 times 14. Okay. Let me just punch this again. So 2 by 9.8 by 0.1 and then we square root that. Okay, supposed to be 1.4. So this is 1.4. So 2 times 1.4 is 2.8. If I take the 2.8 the other side, it becomes negative. So this will be 0.01 V1 is equal to 5 minus 2.8. That's a 2.2. Divide by 0.01. So that means V1, the velocity which the bullet is going to be moving with when it comes out of the block is going to be 220 meters per second. So that is how you go about this one. Is there anyone that is behind? Please, if you have a question, feel free to open your mic. If you are okay, let